Okay, this is chapter 5. And in chapter 5 we're going to be dealing with capacity, volume, mass, and temperature. So it's a big chapter. There's a lot of concepts to cover, a lot of concepts to learn. Not very hard, but you just gotta keep at it, gotta practice. Practice. Okay, so let's do the getting started part. Let's just do some warm-up. Express each number as a fraction or as a power of 10. Okay, so 0.01, you can see that we've gone one decimal point to the right, or one place to the right of the decimal point, and that's equal to 1/10. Let's do B, 0.01, we've gone to the tens column, the hundredths column, so that's equivalent to 1 over 100. C, 100 is equal to, well, 10 times 10 is 100, and 10 times 10 is just 10 to the power of 2. That's an exponent, 10 squared. Let's do D, 0.001. Well, this is to the tens, to the hundreds, to the thousandths column, so this is just 1 over 1,000. 10 is just equal to 10 times 1, or 10 to the power, or the exponent of 1, and 1,000 is equal to, well, how many zeros? We'll just count the zeros, 1, 2, 3. So that's equivalent to 10 times 10 times 10, which is 10 to the exponent of 3, or 10 cubed. Okay? Number 2, round each number to the nearest tenth. Well, to the nearest tenth is one decimal point, and we know that when we're rounding, if it's 5, if the placement beside it is 5 or above, we move the number to the left up 1. So this is 15.47. 7 is greater than 4. So this will be 15.5. We'll round it up to the nearest tenth, because the nearest tenth is one decimal place. Let's do B. 0.308, we want to round it to the nearest tenth, which is this place here. So right beside it in the hundreds column is a 0, so we're just going to round it to 0. We're not even going to round it, we're just going to keep it the way it is, 0.3. C. 9.999, well, we want to round to the nearest tenth. The 100th column is a 9. This has got to go up, and we move that up, it goes to a 10, but we've got to move that over to on the other side of the decimal, so this is going to be 10.0. And 1.05, well, we want to round this to the tenth. This is a 5, so we move this one up 1, so this will be 1.1. It says use mental math to calculate. Okay, well, because we're multiplying by a number that has a lot of zeros in it, 4.3, all we need to do is just move the decimal point to make it bigger by 3 spaces. Okay, so this will be a 4, and then it'll be a 3, and we'll move the decimal point 3 spaces. 1, 2, 3, and we have those 2 little loops, we put zeros in there, so this will be 4,300. We don't even need to use our calculator for that. 4.3 times 10 cubed. Well, you notice that 10 cubed is the exact same number as 1,000, so this is still the same number, 4,300. Okay. 4.3 divided by 0.001. Well, when we're dividing, we're going to be, when we divide, if we were to multiply this, we'd move it this way, but because we're dividing by a smaller number, we're going to be moving it to the right, so this number is also 4,300. What we can do is I can show you on the calculator. 4.3 divided by 0.001, and you can see we end up with 4,300. Okay, so when we're dividing by a very small number, you'll notice the number gets larger. Okay? All right, so 4.3 divided by 1 over 1,000. Well, we know 1 over 1,000 is the same number as 0.001, so this answer is also 4,300. Okay, so notice how we get the same answer, 4,300, but look at the mathematical operations, how different they are. Okay? 5.6 times 0.6 times 100, well, you do that column there. Okay, you can use your calculator if you want, but try to use your head. Try to use mental math to do it. Okay? Write the missing numbers. Multiplying a number by, now this is kind of in conclusion here, to follow what was the principle that's up here. Multiplying a number by 1,000 gives the same result as multiplying by 10 cubed, or dividing by 0.001. And you can see that's why we have all the same answers up above here, 4,300. Dividing a number by 0.01 gives the same number result as multiplying by 10 squared, or 100. Okay? Express each fraction of an inch as a decimal. Well, 1/4, we can take our calculator and do 1 divided by 4, and we get 0.25, or 1/4 of an inch. 3/8, we can take our calculator, do 3 divided by 8, and we get 0.375, I believe. Let's just double check that. 3 divided by 8 equals 0.375. Okay, 1/16 of an inch, well, we can use our calculator for that. 1 divided by 16, because 1 over 16, that's all it means is 1 divided by 16, and we get 0.0625. 0.0625. And 7/16, again, we can use our calculator for this. 7 divided by 16. Notice how when we're dividing it, the calculator puts the line in there for us, so it looks like a fraction, and we get 0.4375. 0.4375. Okay, so solve each equation. We have the fraction 2 over 5. That's equivalent to what over 15? Well, if we want to solve this, we just look at the relationship between the two denominators. We got 5 to 15. Now, what is the difference between 5 and 15? Basically, 5 has been multiplied by 3 to get 15. Well, if we want to have the same ratio, because this is just ratio and proportion, if we want to have the same ratio, if we multiply the bottom by 3, we multiply the top by 3. So 5 times 3 is 15, 2 times 3 is 6. So the fraction 6 over 15 is the exact same fraction as 2 over 5. Okay, we could have also solved this by cross-multiplying. Whenever you get an equality like this, you can do the simple algebra of cross-multiplying. We can take 2, multiply it by 15, and that's 30, and we take that answer 30 and we divide it by 5, we get the answer 6. So there's two ways you can do it. You can do it by seeing the relationship between the denominators and having the same relationship on the top, or you can cross multiply. Either way works, and you're going to have situations where you have to do both. Okay, so 8 on the bottom of the first one to 40. Well, how do I get 40 from 8? Well, I multiply by 5. And what I do on the bottom, I have to do on the top. So 8 times 5 is 40, 5 times 5 is 25. So the fraction 25 over 40 is the same as 5 over 8. Okay, let's do this one. 9 to 27, or because we want to fill in this box here, we're going to go this way. Okay, so 27 to 9. How did I get 9 from 27? Well, I divided by 3 going this way. 27 divided by 3 is 9, so I do the same thing on the top. 9 divided by 3 is 3. So I can say the fraction 9 to 27 is identical to 3 over 9. And then, even though the box is on the bottom here, we can still do the relationship between the numerators. 3 to 6. Well, I multiplied by 2 going this way. 3 times 2 is 6, so I take 1 times 2 is 2. So 3 over 1 is the same as the fraction 6 over 2. Okay? So let's go and do a couple on this side. All right, so write the integer for each letter shown on the number line. Okay, so we have to know what an integer is. You remember from junior high that an integer is all the numbers positive and negative, including 0. No fractions, no decimals. They're whole numbers, entire numbers, but they include negative numbers. Okay, so let's look at the number line here. You can see we have a number line. There's 0 right there, and above this line it goes up by 1s, 1, 2, 3, and below the line it goes down by 1, negative 1, negative 2, negative 3. Okay, so write the integer for each letter shown on the number line. Well, A, if this is 0, this must be 1, this must be 2. Okay. B, If that's 0, this is -1, -2, -3. B must be -4. And C, there's 0, 1, 2, 3, and C is +4. Okay, so not very hard to understand the number line. Now it says label 1, -2, and -1. You can do that. Okay, circle the negative integers below. Okay, notice how it says negative. Underline the positive integers. So let's circle the negative. Okay, well, circle. There's a negative number, there's a negative number, and there's a negative number. And then it says underline the positive. Well, positive integers right there. Notice how we did not do 0. Which integer in part A is not circled or underlined? 0. Why or why not? Because it's neither positive or negative. Okay, it's neither positive or negative. It has no value. Okay? Write greater than or less than to make the true statement. -4 is greater than or less than 4? Well, we know it's less than 4. And less than, the arrow points to the smaller number. The open spot on that arrow points to the larger number. Okay, -1 is greater than or less than -4? Well, if we look at the number line, which one is closest to 0? -1 or -4? Well, -1 is closest to 0. Okay, so -1 is greater than -4. 0 is less than or greater than -5. Well, 0 is greater than -5. And -6 is greater than or less than, or -7 is greater than or less than -6. Well, as we go larger number negative, it gets further away from 0. Okay, so -7 is less than -6. Calculate 1 minus 3. Okay, what we can do to help you understand here is 1 subtract 3 is the same as 1 plus -3. Okay, 1 minus 3 is the same as 1 plus -3. That's one way of looking at it. But if we go to the number line, if we start at 1 and we're taking away 3, that means we're getting smaller. I go this way, 1, 2, 3, and that's the answer right there, and that spot is -2. Okay, so 1 subtract 3 is the same as 1 plus -3, which gives us an answer of -2. Okay, B, -2 subtract bracket -6. Okay, well, what we can do is when we're subtracting a negative, that's the same as adding a positive. So this is -2 plus +6. So if I start on the number line at -2 and I want to add 6 to it, I just count 6 spaces up. 1, 2, 3, 4, 5, 6. And that answer is +4. So -2 plus +6, or -2 minus -6 is +4. 0 subtract -5, that's when we subtract a negative, we can just say that's the same as adding a positive. So this is 0 plus 5, and 0 plus 5 is just 5. And -1 minus 4, well, we can go to our number line. -1 subtract 4. So when I'm subtracting, I'm going smaller. So if I'm at -1 and I'm going to -4, I'm going starting at -1 and go 4 spaces. There's 1, 2, 3, and it would be 4 would be right here, and that is -5. So I can say that -1 subtract 4 is -5. Okay? 11. If necessary, round to 1 decimal place. So I have 9/5 subtract 3. Or that's not 9/5 subtracted, that's 9/5 times -3. Okay, so there's 2 ways we can do this. We can take our calculator and do 9 divided by 5 first, as it says over here. Okay, and then we can multiply it by negative 3, or we can just say that this negative 3 is the same as negative 3 over 1, and we can multiply 9 times negative 3 on the top, which is negative 27, or sorry, negative 27 over 5. Okay, negative 27 all over 5. Okay, or we can take our calculator, and I'll just put it over here, turn it on, clear it, and we can take 9 divided by 5, and we can hit equals, and we can take that number and we can multiply that by negative. Now here is the negative sign right here. Okay, so don't use the subtract sign to put in a negative number. You must use this one right here. Times negative, and notice how the little negative sign comes up here, times negative 3, and I get an answer of negative 5.4. Okay, negative 5.4. Let's just see if that's the same as negative 27 divided by 5. So if I take negative 27 and I divide that by 5, and I get the same answer, negative 5.4, which is equal to negative 5.4. Okay, so this is the same thing, 5/9 times negative 8. I can take the 5, multiply it by the negative 8, which is negative 40, over 9, and I can leave that as an answer as a fraction, or I can take my calculator and I can take 5/9, 5 divided by 9, hit equals, and I can multiply that by negative 8, and I get an answer of negative 4.44. So it says round to one decimal place, so we'll say it's negative 4.4. Okay? All right, so I think I'm going to stop right there. I think you can do the rest of the questions 12 and 13 on this chapter, and then we'll get on to 5.1. Okay?